Thank you, Diane.
Great, thanks, Wes. Okay, let's get started with our speakers. Our first speaker today is Todd Lindley. Todd is a Science and Operations Officer at the National Weather Service in Norman, Oklahoma, and served as the chair of the NWCG Satellite Data Task Team. Let's get the presenter role transition to him.
Thank you. Now I'll just start showing my screen here as soon as the prompt comes up. And let me know when you can see my full screen.
Looks good, Todd.
Looks like I see it.
Okay, very good. Well, thanks for the invitation to speak to the webinar today. I appreciate that. Again, my name is Todd Lindley, and I'm the Science and Operations Officer at the National Weather Service Forecast Office in Norman, Oklahoma. And I'm just going to briefly talk today about the NWCG Satellite Data Task Team and the report that we submitted to the Fire Environment Committee earlier this summer. And I would like to start with this image that you see here. Please keep that in the back of your mind as we progress towards the end of the presentation. That's a glimpse into our operations area here at the WFO in Norman. And one of our forecasters, Randy Bowers, as he's interrogating multispectral satellite data from GOES 16, or what we call GOES East, during a fire outbreak in Northwest Oklahoma back in November, a year ago now. And what I want to call attention to is his use of various, like I said, multispectral bands of satellite data. Also, you can see Google Earth, actually Street View on the right side, but also look just behind him, one of our television meteorologists from the Oklahoma City media market covering the fires as well. And you can see the little banner above him that says View from Space. So we're not the only ones using this. Our media partners and the public are using this information too. So I won't go through this line by line in the interest of time, but just to show you that we had a diverse task team that was constituted of we had subject matter experts from 10 different agencies, including not only the National Weather Service, of course, but state forestry agencies, U.S. Forest Service, Predictive Services, some of the folks there in Boise as well, and BIA, and from across the country. The motivation for the task team was really the deployment of the GOES 16 and 17 satellites over CONUS. And a lot of the innovation that has come about as a result of the new capabilities provided by these high resolution, high temporal resolution satellite instruments that we now have in orbit. And some of that innovation was noted by our chief operating officer in the National Weather Service that as taking place faster than the organization could really consider policies and guidance. We were having a lot of success, especially here in the Southern Plains, with the use of this new technology as far as providing early notifications that were credited with saving some lives and property. By the way, this animation that you see here is from March of 2017. We burned 1.2 million acres in a single burning period, and this occurred just 2 days after the GOES 16 imagery became operational. So that was quite an eye-opening experience to see the capabilities and what all kinds of detail you could see with the fires. So as a result, this is a copy of the tasking memorandum from the Fire Environment Committee, Robin Heffernan, and the task team was assigned to investigate the current and rapidly evolving state of satellite-derived wildland fire data science and technology, and to identify service gaps that were currently ongoing with prototypes and other experimental pilot projects from the partnering agencies, and also to propose a comprehensive interagency set of requirements for the delivery of satellite-based products and services that address the need of the wildland fire community. Now, as part of that, we recognize that the logistics of which agencies, which partnering agencies satisfied satisfied these potential requirements was really beyond the scope of the task team. And to kind of emphasize that point, I included this quote from Dr. Stephen Pine in his book Tending Fire. The fact is that technology can enable but not advise, while science can advise but not decide, and that synthesis belongs with the politics. So the task team really tried to stay on task and stay in our swim lane as far as not really advertising or advocating for any one agency to fill these particular service gaps, just to identify them. Again, I won't go through the timeline of the task team's activities in detail, but as you can see, it was a very busy 2-year period, especially when you throw in the pretty major disruptions that we had with the partial government shutdown and also the pandemic. But just to point out that this task team really began in earnest in September of 2019. We were able to make our final report to the Fire Environment Committee in August, and then a couple weeks later, the executive board, and the report was finally published in early September. And not about a month after that, we were able to actually publish a journal manuscript that validated some of the science that we advocated in the report. So the final report is 35 pages in length. It contains 40 paired findings and recommendations and identifies 4 service gaps. I think there are probably a lot more than that, but those are the ones we emphasized. It also included real-world examples of the use of some of this technology, and also included some customer testimonials about the successes that we have had, and of course was fairly heavily referenced and cited. So if you had to summarize the information within the report, I would say this, that the real-time detection and monitoring capabilities represent the core technological advances offered by modern satellite-based platforms for wildland fire services. And to kind of illustrate that, this is one of our testimonials from a longtime fire chief in West Texas, referencing some hotspot notifications that they were receiving based on the Ghost 16 imagery. He says he's been in the fire services since 1974, and that one of the most impressive and most useful tools that they have seen developed during those decades was this the implementation of the Ghost 16, 17 in identifying hotspot notifications and the use of that, and how accurate and dependable and vital that had been to his agency's survival during the wildfire season in West Texas. So one of our executive findings was that the modern satellite-based wildland fire detection capabilities, especially those provided by the GOES-R series, which include GOES East, GOES West, have the potential to revolutionize the provision of life-saving warnings for both public and first responder safety during dangerous wildfires. And this was kind of captured by a Washington Post reporter in November 2018, not long after the Camp Fire, where he stated that the National Weather Service has satellites that can sense a developing hotspot, and with up-to-the-minute technology and rapid refresh models can anticipate what that fire will do next, and that therefore meteorologists could alert folks downwind in the projected path. So to summarize our recommendations that we made to the Fire Environment Committee and on to the Executive Board, we stated that the NWCG should formally recognize the criticality of real-time wildfire detection and monitoring by modern satellite platforms. Namely, again, the main emphasis of the group was GOES 16 and 17, but we'll also discuss some of the polar orbiters, JPSS, NOAA 20, and that we should work with stakeholder policymakers to institute standards for delivery of essential fire notifications, fire intelligence, and fire warnings based on an assimilation of all available space and ground-based remote sensing technologies, of course, to promote safety. Should also encourage development of future satellite capabilities and also consider the appropriate roles of private versus public sector interest. And we ask that you don't just take our word for it, but there was also a very excellent report that was a joint venture between the Department of Homeland Security, the U.S. Fire Administration, and FEMA, issued in late May of 2019. And finding 17 of our report actually corroborates their key finding number 1 and number 2, which, just to summarize, says that we should implement and scale the use of state-of-the-art remote sensing assets to provide state and local stakeholders with real-time, accurate, and low-cost ignition detection and tracking information, and also to improve the availability of public alerts and warning technologies to deliver more targeted, effective messaging to the whole community, not just the fire community, but to the public as well. And the authors of that report stated that if we do that, we would substantially improve the immediate life-saving efforts during damaging fire events in the urban wildland fire environment and interface. So just to familiarize yourself with some of the instruments, there are a whole host of polar orbiters that we looked at, and also the geostationary. And like I said, the geostationary satellites, GOES 16, 17, and some of the new innovations we were seeing with the high temporal resolution from those instruments was really the impetus for this task team and our research. However, we've had discussions with Zeke and some of the other folks at high latitude, certainly in Alaska, and we definitely recognize and understand and stated in our report that, you know, our recommendations for CONUS using the geostationary satellites by in no means mitigates or trivializes any of their work that they've done at high latitudes, because you see the polar orbiters have a much more frequent pass over the higher latitudes in Alaska and parts of Canada, whereas with the geostationary we can get up to minute by minute views over CONUS. So we organized our key findings, tried to organize them in a way that resembled the response to an incident. So we have a section on preparedness, one on support of initial attack, one on support of extended attack, one on smoke and air quality, and one on recovery. And of course, the core of those findings and recommendations are really based on real-time monitoring and detection. And this is from a paper back in 2016. We state that the remote sensing tools in the GOES R-era and beyond greatly increase the capabilities and the role of fire meteorologists towards tactical impact-based decision support services and firefighting operations. I think that's a big deviation, certainly for the National Weather Service, which in my view had more of a strategic role in identifying and issuing outlooks for critical fire weather watches, fire weather warnings. But these new technologies allow us to focus more on the actual fire scale and some of the changes occurring there. In the realm of preparedness, I think it's very important to state that most of our agencies aren't very prepared to leverage this new technology that we now have available, and that we really need to promote development of operationally relevant training for, you know, fire behavior analysts, meteorologists alike across the community to leverage these technologies. And we also need to emphasize to the policymakers that this data is really critical, and that real-time satellite-based detection and monitoring of fire is really vitally important. And also, of course, to coordinate guidance and reportable thresholds for criteria for satellite-based fire. You can always find satellite-based fire, and, you know, a lot of fires are prescribed, right? Not all are damaging wildfires. Much of the fire on the landscape is fairly benign. So we don't want to report everything that we see via the satellites. In the area of support of initial attack, it is really about the earliest possible but accurate real-time hotspot detections, and that's probably the biggest feedback we received in our, you know, in our study and in compiling the report. And again, that goes back to another quote from Dr. Pine. Between two fires, he stated, the fact that never changes. The safest and least costly fires are the ones that receive strong initial attack and are suppressed while they're still small. And what you see in the bottom left is a prototype kind of proof of concept that we've developed in Oklahoma in coordination with Oklahoma State Forestry and Oklahoma Office of Emergency Management. It's a text/GIS system where forecasters can send notifications immediately when they detect new fire starts in critical environments. And we've had upwards of 80 to 85% success with those notifications being received prior to local 911 calls on the ground. So in the future, could real-time detections like that be coupled with weather fire behavior models and maybe be a basis for futuristic fire scale warnings? In the realm of support of initial attack, the task team advocated to develop guidance and operating plans for the issuance of satellite-derived fire intelligence on changes in the burn character or the fire environment. And this would be in support of tactical operations around the fire. What you see at the bottom left is the Ray Fire, a 280,000+ acre mega fire in Northwest Oklahoma in April of 2018. And all of those individual dots are notifications that were sent when meteorologists detected changes in the fire behavior or the fire characteristics via the GO16 imagery, they would send a notification to the teams deployed to that fire and alert them of what they're seeing from kind of that 30,000 foot view, right? And not only changes in the burning character, but also changes in weather, maybe a wind shift approaching or a thunderstorm approaching, what have you. We also support scientific efforts to improve automated output related to monitoring effectiveness and suppression, predicting pyrocumulus and other predictive signals for extreme fire behavior. We kind of did a summary of some of the literature and the conference material that was out there that leveraged satellite, some of it actually mosaicing it with terrestrial Doppler radar networks, for instance, to identify commonalities when you have extreme fire behavior and extreme wind events associated with pyrocumulus, for instance. So all of those things need to be promoted, and there needs to be an emphasis on the science going forward. The area of smoke dispersion and air quality really is not my area of expertise, but we had Susan O'Neill on the task team, and it is hers. So she authored that portion of the study. But really, the smoke and air quality community really asked that we focus on improved algorithms, for instance, for fire detection, because that feeds the smoke models, of course. And also, one thing that really struck me is we currently have no way of sampling a vertical cross-section or a vertical profile of smoke and particulates in the atmosphere. This is one example from Calypso, which is actually a NASA/French Space Agency collaborated instrument. And you can get that from that instrument, but it only passes over any given place on Earth about once every 2 weeks. So it is not operationally useful. And in recovery, there are some very exciting pieces of a puzzle, I think, that are coming together to support the recovery phase. For instance, the use of the JPSS VIIRS bridge, which can, as soon as you get a clear picture that's not obscured by smoke or clouds over a fire, you can get an estimate of the burn severity. It seems to approximate the bear surveys that follow up fairly well and would be available, in very short order on the matter of hours or days. And is it possible that you could take information like that and assimilate it with terrestrial-based radar networks that use hydrologic models, like one called FLASH, to improve flash flood, mudslide warnings in the post-fire environment? The task team, or at least a subset of the task team, partnered with a group that was creating some operationally based training on the use of satellites in operations for fire from Comet Met-Ed, and also with the GOES algorithm developer at SIMS in Madison, Wisconsin, and a few other folks, including the Alert Wildfire PIs out at the University of Nevada in California, to produce a manuscript that was just published a few weeks ago in the National Weather Association Journal of Operational Meteorology. And in this manuscript, we documented how GOES 17, GOES West, actually detected the onset or the ignition of the Kincade fire in Northern California a year ago, last October, within 52 seconds of ignition. And that's by comparing the GOES 17 imagery directly to the alert wildfire footage collected on the ground there by the near IR camera sensor. Okay, so we started with that glimpse into the National Weather Service Norman office's operations during the November 2019 fire outbreak in Northwest Oklahoma. So I quickly want to run through this example of what operations look like today and what they could look like in the future. So at 2:34 p.m., forecaster noticed a hotspot developing in northern Ellis County to the northwest of Gage, Oklahoma. Hotspot notification was issued at 2:34. Oklahoma Forestry Services were able to begin rolling a task force that was pre-positioned just 15 miles away at 2:35. So within a minute, and of course, based on our experience with the Kincade fire, that's likely within 2 minutes or so of the fire actually igniting, task force is rolling. Half hour later, at 3:06, forecaster notes that the shortwave IR brightness temperature is 126 degrees C. That's the highest of the day from any of the fires in northern Ellis County, and then follows up saying that the northern Ellis County fire could be life-threatening at that time. About 15 minutes later, PyroQ developed, signature in Ellis County is still what we would consider life-threatening. Half an hour later, all this information is being passed from OFS onto the local IC. And then about 4:07, an hour after we first indicated that extreme fire behavior was being detected, the town of Fargo, Oklahoma was evacuating. We go forward about 4:10, we pass on to Oklahoma Forestry that we are getting a fire warning ready, but we usually don't get requests for the fire warnings from Ellis County. You see, the National Weather Service has a product called the fire warning, but it is only a pass-through product. It has to be requested from a local emergency manager, that, and it generally contains information about ongoing evacuations and giving instructions for those. OFS shared that information with the local EM, but that EM was unfamiliar with that process. So they had to get the neighboring EM from Woodward County to coach the Ellis County EM through the process. Meanwhile, we're drawing the polygon, awaiting details. They say they're trying. We say no pressure. We're ready. We have it ready when you are. The head fire was indicated to be 2 to 3 miles northwest of town. They're getting frustrated with dang it. And then the request comes in. Finally, that warning was issued 82 minutes after the initial detection of life-threatening fire signatures via GO-16. So what the task team proposed is, if a forecaster knows the fire environment, they have some quantitative measure of fuels and they know the weather, and they have a matrix that shows how likely extreme fire behavior might be, and then they couple that with the satellite detected remote sensing indications of extreme fire behavior, what if that warning could have been issued upon that initial indication of extreme fire behavior from the satellite, say at about 3:08 to 3:10? What if the warning could have been issued there? That would have given you about an hour's lead time before local officials on the ground saw the need to evacuate the town of Fargo. And we asked, would that meet the findings number 1 and 2 from the DHS, U.S. Fire Administration FEMA report? And we think it would. So where are we today in this paradigm? Preparedness, the technologies exist now. We think the infrastructure exists, pending additional testing and guidance policy. Supportive initial attack, very similar. Again, that's something that we could do today, pending additional testing and policy. Supportive initial attack, that's something that is in the near future. A lot of these concepts need further development. And in support of smoke and dispersion, that seems to be something that's a little further out there in the future. We may need to advocate for adding instruments in orbit that would be more beneficial for that realm. And then recovery, again, a lot of pieces to that puzzle coming together. Seem to be a lot of good technologies that we could apply to that in the near future. Again, just highlighting our task team report and also the report from Homeland Security, FEMA, and also the National Weather Service conducted a service assessment following the Camp Fire. That's also a very good document as well. And with that, I will take any questions if we have time.
You know, Todd, I think we're going to postpone the question and answer session to the very end, and then we'll hit them all, and then we'll dole them out to the speakers that they're relevant to. Is that okay?
That's perfect. Thank you.
Okay, fantastic. Thank you, Todd.